Hi friends, welcome to our YouTube channel Agricultural Engineering. Today we are going to see the soil and water conservation structures. From that topic we are going to see watershed and its management. What are the important points from this topic? So first is definition of watershed, which is they will ask what is the definition of watershed. So the watershed is defined as an area enclosed within a watershed line. Okay, or there are some one more definition. Okay, after that there are different classifications based on the area of watershed. So all India Soil and Land Use Survey in 1990 they have given classification. Watersheds are classified based on five types based on area, divided into five types. So first is macro watershed, the area of watershed lying between 500 kilometer square to 2000 kilometer square. Then sub watersheds, which is having area between 100 and 500 kilometer square. Milli watersheds with area between 10 and 100 kilometer square. Mini watershed with area between 1 and 10 kilometer square, and micro watershed with area less than 1 kilometer square. After that, what is the scope of watershed that you can go through? After that, remember this, fill in the means of full form. PET stands for potential evapotranspiration. Then soil conservation research demonstration and training centers, SCRDTC, by the Ministry of Agriculture, MOA, of the Government of India, GOI. So remember this full forms in case they will ask. Now here one more full form: Central Soil and Water Conservation Research and Training Institute, Dehradun. Then Operational Research Project, ORP. Then Drought Prone Area Program, DPAP. This you remember from exam point of view, DPAP, Drought Prone Area Program. Then Desert Development Program, DDP. Then Flood Prone Rivers, FRP. Then CRIDA, Central Research Institute for Dryland Agriculture, CRIDA, Hyderabad, which is situated in Hyderabad. Then Western Ghat Development Program, WGDP, and Hill Area Development Program, HADP. So you should know these full forms. After that, this is important full form: National Watershed Development Program for Rainfed Areas, NWDPRA. Remember, and IWDP stands for Integrated Integrated Wetlands Development Program. Okay, so these are some important full forms. We will move to another. Now, what are the problems and constraint? That is not that much important from exam point of view. Now we will go for land capability and its classification. So as you know, the Soil Conservation Service of the United States Department of Agriculture has done a pioneering work in land capability classification. So there are two groups. Group 1 lands comprise land class 1 to 4 which are cultivable, and group 2 lands comprise of land classes 5 to 8 which are non-cultivable. So from 1 to 4 are cultivable, and 5 to 8 are not cultivable. So for getting in detail information, you can go through this class 1 lands, class 2 lands, and class 3 lands. Subclasses. This important point: land capability subclasses. Lands in classes 2, 3 and 4 are further categorized into subclasses based on the following limitations. So see, risk of erosion or past erosion damage is designated by the symbol E. Remember E for risk of erosion. Wetness damage or overflow is designated by symbol W. Then soil root zone limitations are denoted by S. Soil root zone limitation. Then climatic limitations are designated by C. Climatic, C for climate. So there is chance they will ask for match the pairs, or in case of fill in the blanks. So this is important topic from exam point of view. And group 2 lands are non-cultivable. So for in detail, there is chance to ask that slope. See, for class 6 lands having slope ranging to 18%, class 7 having slope ranging to 25%, and class 8 lands having slope more than 25%, class 5 lands having slope in between 8 to 12, class 4 lands having slope in between 5 to 8, class 3 lands having slope between 3 to 5, and class 2 lands is having slope in the range of 1 to 3%, and then class 1 lands are level slope are generally level with slope generally within 1%. Okay, so this is land classification. This is important topic from exam point of view. Now watershed based land use planning, in this case, is there any important point? Equity and acceptability, sustainability. So just go through this. This is not that much important, but watershed planning is important topic. Now see, GIS stands for Geographic Information System, and radar stands for Radio Amplification Detection and Ranging. Then what is full form of LIDAR? Then what is Indian Remote Sensing IRS satellite? National Natural Resource Management System NNMRS. So this full form GPS Global Positioning System. You are thinking this very small topic, or why I am telling you full forms, but from exam point of view you should know the each and every full form. So if there is any question, you can able to attempt that one. Now what are the characteristics of watershed? Size. So as we have seen already classification of watershed: small watershed, medium watershed, large watershed. Then land use, based on land use: agricultural watershed, urban watershed, mountainous, forest, desert, coastal or marsh, and mixed watershed. After that, watershed characteristics: physical and geomorphological characteristics associated with watershed: basin area, basin slope, basin shape, basin length, form factor, shape factor, circulatory ratio, elongation ratio, compactness coefficient. Now see, basin area, the area of watershed is known as the drainage area, and it is the most important watershed characteristics. Now basin length can be defined in more than other way. The greatest straight line distance between any 2 points on the perimeter is called as basin length, or the greatest distance between the outlet and any point on the perimeter, or the length of main stream from its source to the outlet. This is also called as basin length. Then there is one formula: LB is equal to 1.312 A raised to 0.568, where A is watershed area in kilometer square and LB is the length of basin in kilometer square. So basin slope, the formula for basin slope is H by L, where H is fall in meters and L is horizontal distance over the fall occurs. Then basin shape, there are different type of basin shape: fern shape, fan shape, watershed. So there is one important question they will ask on based on basin shape: time of concentration. We will come to know that what is time of concentration, but there is one important question they will ask: time of concentration is less in which case, which type of watershed. So there they will give options: fan watershed, fern watershed, both or none of the above. So you have to write the correct answer. For that we will see upcoming these pages. Now form factor, the area of the basin divided by the square of axial length of the basin is called as form factor. Then shape factor, the drainage area divided by square of the main channel length, L square by A. Then circulatory ratio, the ratio of basin area to the area of a circle having the same perimeter as the basin, 12.57 A divided by PR square. Then elongation ratio, the ratio of the diameter of circle of the same area as the basin to maximum basin length. Then compaction coefficient, the perimeter of the basin divided by circumference of equivalent circular area. Then channel characteristics, channel order. So the first order stream are defined as those channels that have no tributaries. The junction of two first order channels form a second order channel. A third order channel is formed by the junction of two second order channels. Thus a stream of any order has two or more tributaries of the previous lower order. This scheme of stream ordering is referred as the Horton-Strachan ordering scheme. So here one important point is a stream of any order has two or more tributaries of the previous lower order. Okay, then bifurcation ratio is defined as the ratio between number of streams of particular order to the number of streams of one higher order, means number of stream of one order divided by number of stream of one higher order. Then channel length, this refers to length of channel, Horton's law of channel length. Then channel slope, the channel slope is determined as the elevation difference between the endpoints of the main channel divided by the channel length. Channel profile, drainage density. Drainage density is a favorite topic for the examiner. Drainage density is the measure of closeness of drainage spacing. It is indication of drainage efficiency of overland flow and the length of overland flow as well as the index of relative properties. It is defined as the length of drainage per unit area, L by A. This term is introduced by Horton. Now we will go for another. I know it's somewhat fast, but we don't have time, so we have to cover. Now here, as I said, effect of physical properties on watershed management. The common watershed may be square, rectangular, oval, fern, leaf shaped, polygon shaped, circular or triangular type. See, a circular watershed would result in runoff from various parts of the watershed reaching the outlet at the same time. An elliptical watershed having the outlet at one end of the major axis and having the same area as the circular watershed would cause the runoff to be spread out over time, thus producing a smaller flood peak than that of the circular watershed. So here, larger the watershed, higher is the time of concentration and more water will infiltrate, evaporate or get utilized by the vegetation. Now another one is drainage area of watershed, length of watershed, slope of watershed. Then effect of geomorphological factors and associated process on watershed management. So these are land use. This is not important. Then hydrologic data for watershed planning. What are the data required for planning of watershed? There is less chance to ask any question from this case. Here are hydrologic data, then climate, then physiographical data, then physical and natural features. I think this is not that much important, so we will go for utility of use of hydrometeorological data in watershed planning. I think here also not important topic. Then watershed delineation. A topographic map is a two-dimensional representation of portion of three-dimensional surface of the earth. Topography is the shape of the land surface and topographic maps exist to represent the land surface. So what is map scale? Vertical scale. All maps have a horizontal scale. Topographic map also have a vertical scale to allow the determination of a point in three-dimensional space. Then what is contour line? Contour lines are used to determine elevations and are lines on a map that are produced from connecting points of equal elevation. Remember this, contour lines, the line joining the points which are having equal elevation. And these are some properties. Contour lines do not cross each other, divide or split. Closely spaced contour lines represent steep slopes. Conversely, contour lines that are spaced far apart represent gentle slope. Contour lines trend up valleys and form a V or U where they cross a stream. Contour lines can not merge or cross one another on the map except in the case of the overhanging cliff. Then contour lines cannot end anywhere but close on themselves either within or outside the limits of the map. So the watershed boundary delineation from contour topographic map. In this case, so they have given steps for watershed delineation. So in this case, you should know DEM stands for Digital Elevation Model, then SWAT stands for Soil and Water Analysis Tool, then one more important definition. So this is steps for watershed delineation. Then what is meant by prioritization? So what are the factors influencing prioritization? Sediment yield index, SYI. This is also not that much important topic. So next is water yield assessment. So what is water yield? The water yield is defined as the amount of fresh water derived from unregulated flow and having unit cubic meter per second measurements for a given geographic area over a defined period of time. So water yield assessment is the water yield of a watershed may either be measured directly on a single outlet on the main stream or be calculated through empirical equation based on important physical properties of a particular watershed. So there is a direct measurement method, then water budget approach, then upstream downstream consideration, then what is the use of watershed. Surface water measurements. So velocity area method, Q is equal to AV, where Q is discharge, cubic is cubic meter per second, A is the area of cross section, and V is the average velocity meter per second. Then this is important point, measuring discharge using a weir. So for a rectangular weir, Q is equal to 1.84 L minus 0.2 h raised to 2 by 3 in meters. For a triangular notch, where the formula is Q is equal to 1.379 h raised to 5 by 2, where h is height in meter, then h is the height of water in the backwaters or weir in meters. Then discharge measurement by tracer method, Q is equal to AL by T. So from exam point of view, you should remember these two formula. For rectangular weir, what is the formula for discharge, and for V notch weir, what is the formula for discharge. Then piezometer, what is the use of piezometer? Mini piezometers are simple instruments for measuring the direction of water flow between groundwater and a surface water body such as a lake or stream. So measurement of lateral flow or interflow. Then watershed modeling. So this is somewhat practical approach, but in case of your exam, they will ask only theoretical questions. So hydrologic design is applied to recharge structure in this topic. In this topic, not that much important. Detention time. Now design of earthen embankment. Homogeneous tank bund type A. Uniform and homogeneous material are used in the construction of this type of earthen embankment. Homogeneous means single. Homo means single. So with the uniform and homogeneous material are used for construction of this type of embankments. Then zoned tank bund. When earth of different types is locally available, the bund may be constructed by dividing the section in different zone. So here you can see there are different zones. So this is zone tank bund. Then diaphragm type tank bund. In this case, many times zoning is done by providing a central core wall called diaphragm. So it is generally constructed with masonry or concrete. So in this case you can see there is one diaphragm, masonry core wall. Then design of tank bund. Then storage capacity of tank. See, this is trapezoidal formula H by 3 A1 plus A2 plus square root of A1 into A2, where V is the volume of enclosed between two adjacent contours. A1 and A2 are the areas enclosed in two contours, and H is the contour interval. So trapezoidal formula for calculating the storage capacity of tank. Now hydrologic and hydraulic design of divergent structure. Now types of weirs: masonry weir, then masonry weir with horizontal floor. These are different types of weir. Concrete weir. So these are some different formulas. So the basic formula is Q is equal to C L H raised to 3 by 3 for 3 by 2 for discharge. C is for 1.84 for weir crest up to 0.9 meter width. So the C value changes. So in this rectangular and triangular notch weir, we have seen the value of C, where is then remaining modules, means 7 modules we have completed. Now 16 means 9 modules we will see tomorrow. Thank you for watching our video.